Math 8, Unit 5 Functions, Lesson 7, Modeling with Linear Functions. First, when you have a linear function, remember those are of the form y equals mx plus b, or f of x equals mx plus b if you're in function notation. You've got your slope, which is your rate of change. It tells you that how the output variable is changing compared to the input variable's change. Y-intercept is, of course that's in the equation here, is the b. It's a starting value for the output variable when the input variable is 0. And then an ordered pair is a pairing of input and output where we're told how those two relate for one specific value. Some things to remember about linear models is that the domain is sometimes limited. You can have boundaries between numbers that work and that do not work because of context, and not necessarily because of the math limitations. A lot of times you can calculate those things, but they won't have any real-world meaning. For example, I could have a domain that is the age of a person who has a driver's license, and that would only include people with an age of 16 or greater. It may be that if I have a function, I could plug in 15 or 14 or 13 into the equation and figure out a number, but it wouldn't make any sense because it's not even in the domain. Okay, another example, the length of a stick. Length of a stick would have to be bigger than 0. A 0 length stick, you wouldn't even call it a stick, it'd be nothing. And a negative length stick doesn't exist. So even though we may have something where we could plug in a negative number, if it's referring to the length of a stick, it can only take positive numbers. Another example, your grading math class, the domain is going to be between 0 and 100% because you can't have a grade outside of that range, well, outside of that domain. Another possible problem that can happen is when only whole numbers or integers work in a function because of the context. And this was the idea of discrete and continuous functions. Discrete inputs or discrete domains are ones in which only certain numbers work, and continuous, you have a whole range of numbers that can work. For example, a discrete variable could be the number of people, and a continuous variable is something like time, where I can take time and split it into smaller pieces, and it still has value as time. But if I take people and try cutting them into like half a person or a third of a person, they will, if they remain alive, they will retain value as a person. They'd be counted as a person. If not, it would just be body parts, and we wouldn't consider that a person. Just body parts that are no longer living. Anyway, math gets more interesting with real-world limitations. Okay, this following example is not linear, but it gets an idea across. If f of x represents a lunch account balance, given the student number, interpret the following. F of 10566 equals $0. Well, that means the student that has the student number 10566 has a lunch balance of $0. The student that has a lunch number of 11078 has an account balance of negative $13.40. And then the student that has an account a student number of 09814 will have a lunch account balance of 42. And that's just interpreting the function. Let's look at another one. The linear function h of t equals negative 5t plus 300 represents the height in meters of a skydiver t seconds after opening the parachute. Find and interpret h of 5. Well, h of 5 is going to be found by plugging in 5 for the t value and then figuring out what that ends up being. Well, negative 5 times 5 is negative 25, plus 300 is going to give us 275. Now, to interpret that, since h of 5 equals 275, at 5 seconds after opening the parachute, the diver is at 275 feet above ground. Okay? Find the value of t such that h of t equals 0 and interpret its meaning. For this, we're going to find when h of t is 0, so we'll want to plug that into the original equation for h of t. We're going to solve for t here to figure out what value of t is going to make us have an output of 0. So I'll subtract 300, and that gives me negative 5t equals negative 300. Then I'll divide by negative 5, and it looks like t equals 60. So that means that h of 60 equals 0. And what this will mean is that at 60 seconds, the distance off the ground is 0 meters, but we probably wouldn't say it that way. I'd say the diver lands. They get to the bottom of the sky and they get to the ground. Okay, what are the limitations of the domain on this function? Well, the limitations would be the parachute gets opened at 0 seconds. Even though the diver is going to have a location before then, it won't be represented by this function. So it needs to be between 0 seconds and the maximum is 60 seconds. Because after 60 seconds, even though the diver will have a position, they will no longer be representing that position by h of t. Because they'll be on the ground, they'll just be on the ground. They won't be falling anymore. Okay, let's look through some examples now. The Booster Club at Silverton High School decides to make and sell t-shirts displaying the school motto to raise money towards new equipment. The company that will make the t-shirt charges a $200 setup fee plus $4 per shirt. A, write the function c of x that calculates the cost in dollars for the Booster Club to make X t-shirts. Now, in order to write this equation, we need to find slope and intercept. Now, slope tells you how much, in this case, the cost is going to change for each shirt. And for that, the slope is going to be $4 per shirt. So it's going to add $4 for every one shirt. And the y-intercept is the starting cost. It costs $200 for the setup fee. So this gives us a function. C of x is 4x plus 200. That will be the cost of shirts, to buy X shirts. Because it's $4 per shirt plus the $200 setup fee. Part B, does this represent continuous or discrete function? Now, to decide this, we need to look at the input. The input is shirts. Does it make sense to think of shirts in terms of half shirts and third shirts and eighths of a shirt? And we would only buy shirts that are full shirts. So we're only going to buy a whole number of shirts. So I'm going to say this is discrete. Because you'll only buy whole shirts. You're not going to get partial shirts, and then you're not going to take a half shirt and pay $2 for it. If it's a half shirt, I don't want it, right? Okay, C, what is the y-intercept? Interpret the meaning in this problem. The y-intercept here, of course, is 200. And what it means is the cost is $200 to get started. And that's before you've even got any shirts. That's just the setup. Maybe they're doing screen printing and they have to get the screens made to do the screen printing. Okay, next example. Tim has a tin can containing 48 quarters. He decides to take 3 quarters out of the can each day and use them in the school vending machine during lunch hour. Make a table of values showing the number of quarters left in the can after 5 days. Well, my table of values, it's going to include day and quarters. And it said to do it for 5 days. I'm going to start at day 0, where before he's spent any of his quarters, he's got 48 quarters. Then he's going to spend 3 quarters each day. So he'll be down to 45, and then 42, and then 39, 36, and on day 5, he's got 33 quarters left. Part B, write the function that relates the number of quarters Q left in the can after D days. Use this function to calculate the number of quarters left in the can after 10 days. So we're going to create the function q of d. D is the input variable. The unit rate here, or the rate of change, this is going down 3 for every increase of 1 day. So the slope is actually going to be negative 3. And then the y-intercept is the starting value, which here is 48. So q of d is negative 3d plus 48. And then it said to answer after 10 days, so that's q of 10. That's negative 3 times 10 plus 48, which is going to be negative 30 plus 48. That's going to be 18. Does it tell us to interpret? Nope, it's just 18 quarters. That's what's left. Okay, part C. Graph the function and determine the intercepts. Explain the meaning of the intercepts in the context of the problem. All right, to graph this function, we need, well, we start with 48 quarters, so maybe I'll count by 8s here. This is 8, 16, 24, 32, 40, and 48. And then, yeah, let's count by 4s in this direction. Because I know that when you get down to 16 days, 48 divided by 16 by 3 is 16. So it does say it takes 16 days to run out. And that's actually part of what this is asking, is to interpret the intercepts. This right here, the intercept of 48 quarters, means that Tim starts with 48 quarters. And then this 16 down here means that after 16 days, Tim has run out of quarters. I guess I'm missing something on my graph I probably should put there real quick, and that is the labeling. This is quarters, and at the bottom is days. Okay. All right, let's take a look at what's on the assignment that goes with this. Number 1 is talking about a long-distance phone bill from Strata Networks, and there's going to be a few questions about that. The number 2, it gives you information on hot dog sales at a baseball stadium. You're going to do a graph and answer a few questions about it. And then number 3 is a review of exterior angle theorem from Unit 3. Number 4, you need to graph those and find out where they cross. That's solving the solution, or solving the system by graphing. 5 is a review of function notation. 6, also from Unit 3, interior angle sum. 7, it's open-ended. Give me an example of a linear and nonlinear function. And then number 8, I give you a function and you need to come up with a context, a story that goes with it.